All right, Algebra 1, here we go. Quadratic functions, 9-2. All right, essential questions. How do you graph? How do the graphs of y equals ax squared plus c and y equals ax squared plus bx plus c differ? Okay? And there is a slight difference here. You can graph them all the same way, but there's a difference. You know, we talked about some of this in class yesterday. The neat thing about quadratics is you use them all the time. If you get in a car and turn your headlight on, if you go home and you turn your TV on and it's direct or TV or it's dish where you're using a parabolic dish, those are all quadratic functions. That dish graph, okay, where it takes all those signals from a satellite into that dish, that parabolic dish, and it shoots all those signals back into a little receiving cone, sends TV into your house. Or if you're in a car and you turn the headlight on and that bulb flashes, it's not flashing out, it's flashing into that parabolic dish that's behind the light, and that silver parabolic dish sends out the light. Okay, so you know those are all examples that we use all the time in the real world that involve quadratics. Okay, because those are all parabolic dishes, which is quadratic. Okay, so how do we graph some of these? Well, when you take a look at the basic standard form quadratic, ax squared plus bx plus c, first thing you want to do in graphing is find the axis of symmetry and the x-coordinate of the vertex, because you find them the same way. X equals negative b over 2a. Negative of whatever b is over 2 times your a. Okay? That will give you the x-coordinate of the vertex and your axis of symmetry. Okay? The equation of that line that runs vertical down through it. Then the second thing you do is you plug that x value back into the equation for x, into the x squared, into the x, and you solve for y. And that y value you get is the y-coordinate of the vertex. Okay, so it looks like this. If we want to graph y equals x squared minus 6x plus 4, my a is 1, my b is negative 6, my c is 4. Yes, you take the negative with it if there's a minus there. Okay, so negative b over 2a for my x will be negative of my negative 6, because again it's negative of the b, all over 2 times my a, which is 1. Negative of a negative is positive 6 over 2, which is equal to 3. So x equal to 3 is my axis of symmetry. The x-coordinate of my vertex is 3. I take that 3 and I plug it back into the x in the formula to find y. 3 squared is 9. 6 times 3 is 18 plus the 4. 9 minus 18 is negative 9 plus 4 is negative 5. So my vertex is 3, negative 5. Okay? Now I know my a is 1, it's positive, so I know my graph's going up. So there's 3, negative 5. There's my axis of symmetry, so my graph just U's right in there like that. Okay? And you can find the particular values if you wanted by taking like 2 or 1, 4 or 5 and plugging them into the equation and find out what y is, and you could plot those exact points. Okay? That's basically how we do it right there. Let's take another look here. Y equals x squared plus 2. Okay, this is the other case where b is 0. Okay, well, let's do it the way we've been doing it. Plug it, find my x, negative b over 2a. Well, my b is 0, so it's just going to be 0. So x equals 0 is my axis of symmetry. It's right here, it's the y-axis. I plug in the x of 0 into x. I get 2. So my vertex is 0, 2, so it's up 2. My a is 1, so I know I'm going to u up. Okay? And the thing about some of this here is this. If b is 0, okay, then your vertex is going to be 0 for x, because you'll always get a 0 there, and the c term. Whatever your c is, that's going to be the y-coordinate of the vertex. And the axis of symmetry, of course, is going to be x equals 0, because the x-coordinate and the axis of symmetry have to be the same. Okay? So you can do them the same way. This is just a little shortcut. When you see that there's no b, because b is 0, then you know that the vertex is going to be 0, c, and the axis of symmetry is x equals 0. That's just a shortcut there. But we're going to do this predominantly, x equals negative b over 2a, and then plug that in for x into the equation and find y to find our vertex. Look at our a value, and it tells you if you're opening up or down. Okay? And we know if it's going to be steeper or flatter depending on that a value. We got that out of the last section. So we'll kind of incorporate that more and more as we go. And we'll look at some of this in class tomorrow. Okay, see you then. Bye.